Hello guys, welcome to Dr. Science. So today we are going to talk about the G protein coupled receptors. In this video I will talk about the definition of G protein coupled receptors, and in my next video I'll talk about the different types of G protein coupled receptors such as your G stimulatory, G inhibitory and GQ subtypes. Okay. So first we will talk about the definition of G protein coupled receptors. So here is the plasma membrane, and to this plasma membrane we have a receptor, and this receptor is passing 7 times through the plasma membrane. Hence they are called as your 7 pass receptors. Not only that, we have 3 proteins attached to the plasma membrane, which are your alpha, beta and the gamma proteins. Now these proteins are also called as your G proteins. Now why they are called as your G proteins? Because to the alpha subunit there is a nucleotide getting attached, and this nucleotide is your guanine nucleotide. Hence they are also called as your G proteins. Now they are also called as your hetero. Hetero means they are different from each other, and heterotrimeric, since they are 3 protein. Heterotrimeric complex. G proteins are also called as your heterotrimeric complex. Now these G proteins coupled with the receptors are called your G protein coupled receptors. I hope you are clarified with the definition. Now let's talk about the activation of G protein coupled receptors. Now we will see what is going to happen in the phase of activation of G protein coupled receptors. So here is a plasma membrane, and here is the receptor, the 7 pass receptor. And not only that, we have the alpha, beta and the gamma subunit. Okay, suppose if there is a ligand or any ligand or hormone is attached to the receptor, there will be receptor activation, and this receptor activation will go and stimulate the alpha subunit of the G proteins. Now this alpha subunit will convert the guanine diphosphate into guanine triphosphate. Okay, so once again, whenever there is receptor activation, the alpha subunit gets activated and it will convert the GDP into GTP. During this step, the alpha subunit will get separated from the beta and the gamma subunit. Okay, they are getting separated from each other, and this alpha subunit together with the newly formed compound, which is your guanine triphosphate, will go and visit a complex. Now this complex is your adenyl cyclase. Okay, now this adenyl cyclase will convert the guanine triphosphate into cyclic AMP. Eventually the cyclic AMP will get converted. Cyclic AMP will go and activate the protein kinase A. This protein kinase A will do phosphorylation of the proteins. Okay, so here this one is a little bit complicated, so I will break it down for you guys. So here is the alpha subunit. Alpha subunit is going to have a nucleotide which is your guanine, but this guanine is only having 2 phosphate attached to its tail. Hence it is called as your guanine diphosphate. Now I already told you, whenever there is receptor activation, during receptor activation, a phosphate is going to get added. What is going to get added? A phosphate will going to get added to the alpha subunit. And not only that, the alpha subunit will get separated from the beta and the gamma subunits. And eventually this is the alpha subunit, and to this alpha subunit we have the nucleotide which is your guanine, and during this step a phosphate was added, right? So 3 phosphates will be delivered here, which is your guanine triphosphate. Now as you can see here, the alpha subunit have a scissor it is having a seizure. Now what is this seizure? This seizure is going to remove the phosphate here. Okay, whenever this phosphate is going to get removed, this guanine triphosphate will again get converted into guanine diphosphate again. Now what is the seizure present here? The seizure is nothing but an enzyme called as your GTPase. Now this GTPase enzyme is an intrinsic enzyme which is present on the alpha subunit. Okay, and eventually it will remove the phosphate from the guanine triphosphate. Now what will happen? This phosphate which is getting removed will get deposited in the adenylyl cyclase. Okay, so the phosphate is going to get deposited in the adenylyl cyclase, and thus it is converting the GTP into, by utilizing the phosphate, it is getting converted into cyclic AMP, and eventually the cyclic AMP will activate the protein kinase A, which is an enzyme, and this protein kinase A will does phosphorylation of the proteins. Okay, so that was about the introduction of the G protein coupled receptors. Now before ending the topic, I would like to show this small diagram. So here is your 7-pass receptor. This is your 7-pass receptor, and here is your alpha, beta and the gamma proteins. As you can see here, alpha, beta and the gamma proteins. To this a nucleotide is attached, which is your guanine diphosphate. Now as you can see here, there is no hormone, so there is inactivation. Now if there is hormone present, there will be activation of this receptor, and this activation will lead to alpha subunit. Okay, as you can see here. Okay, let me change this one. So as you can see here, the hormone is going and getting attached to the receptor, and this will lead to receptor activation. And when there is receptor activation, the alpha subunit, which is having GDP, will get converted into GTP. Okay, and during this step, the alpha subunit will get separated from the beta and the gamma subunit, and it will go and attach to the adenylyl cyclase. And during that step, the GTP, the phosphate, is going to get utilized by the adenylyl cyclase, and it is converted into cyclic AMP and protein kinase A, and finally phosphorylation of the proteins. So that was about the G protein coupled receptors introduction. Thank you guys.